Okay, hi and welcome to some video notes on solving systems using elimination. Don't forget to check out our other videos on how to solve systems by graphing and by substitution. You can find them on my YouTube channel or in the appropriate spot. All right, so today by elimination, let's quickly talk about that. What we're going to use is we're going to use the properties of addition or subtraction. I tend to favor the addition in doing that. So we're going to take both of our equations, our functions. These are going to be linear, right? So we're focusing on linear functions currently. And we're going to stack them up so that we have columns of like terms, meaning that the x's are over the x's, or the variable of independence is over the independence, and the dependent variable is over the dependent. And the tricky part is make sure that your equal sign is over your equal sign, and finally your constants are over your constants. If you line them up, however you do this, in this particular case they're in standard form, so we've solved for C. If you do that and they're all in these nice neat columns, you can use the property of addition or subtraction to eliminate, get rid of one of the variables. Because again, we can only solve if we have one unknown. So by making one of them turn to 0 using addition or subtraction, then we're left with just one variable. So we're adding them just like adding 2 plus 2. That's really what we're looking at. But our goal here would be adding 2 plus negative 2 and having it something turn to 0. That's what we want. So if we look at them like an addition or a subtraction, draw a little line here for addition. I prefer addition. So if you're going to use addition to add these together, then you would want them to be the same and opposite. So one of these two AX's here, for generic sakes, needs to be a negative. So whatever you do, you need the coefficient to be negative on one, but the same value. They're both A, so both 4 or both 2, just one's negative. And then I like to add them together. So that whole column would turn to 0. And then we'll get some value for here, and we'll get some value for C. So we'll have some value of y equals some value of C with one variable, and we can solve. That's what our goal for elimination is. So, short, sweet notes of it is arrange the variables into columns. Again, like terms is really what we're saying here. Arrange them into like terms. Doesn't have to be standard form. Traditionally, I like to put it in standard form, and I think a lot of other people do as well. I prefer addition, where addition is you'd want the equal or same coefficient and opposite sign. If you wanted to do subtraction, just make sure they're equal, but then don't forget if you subtract, you need to multiply all the values by negative. I don't prefer to do that. So I'm going to show you addition in these notes. Of course, when you're done doing that, you're going to get one of the two coordinates. You're not going to get both. Okay, so that means that we do actually have to use substitution to plug back into the original equation, and then we'll solve for the other one so that we end up with both coordinates, because when we're done, a solution to a system of equations has an x value and a y value, and we call it a point. All right, let's see one quick example. So we're going to zoom in here. So solve by elimination. Here's our system. We've got the two equations here, two linear functions. And the first thing that we want to check is that we are in like term columns. So x's over x's, check. Y values over y values, check. Equal sign over equal sign, check. And constants over constants, check. We are all set up to do elimination. That's the first thing. So let's go ahead and check to see if we're ready to turn one of these two variables into 0. If not, we have to make it do that. Right now, let's see if we can. 4x, positive 4x, and negative 4x. Yes, if I add those two together, they're going to turn to 0. Great. And then I need to make sure that these are in the columns. They're going to add, and they're going to add. So we're good to go. My y values and my constants will be the only thing left over. So let's add. 4x and negative 4x will turn to 0, leaving just 8y plus 2y, which is 10y. Drop your equal sign down. 20 and negative 30 leaves a negative 10. And this is an equation with one variable, so now I can solve it. I'm going to divide by 10 on both sides. I'm going to get y equals to negative 1. That's my first coordinate. So now having that, I need to substitute because y is equivalent to negative 1. So in either of these equations, if I change y to negative 1, then I only have one variable again, and I can solve for the other coordinate. So I'm going to plug it into the second equation right there. So I'm going to get negative 4x plus 2 times negative 1 this time instead of y, right, because they're equivalent, equal to negative 30. Now I've got one variable, this time it's x, and I can solve for that. So I'm going to go ahead and clean this up. So I get negative 4x minus 2, those two make a negative 2 equals negative 30. Now I'm into my solving process, and remember addition and subtraction should be first before multiplication division, so I'm going to move this 2. So I'm going to add 2 to both sides. I'm going to get negative 4x is equal to negative 28. And then I'm going to do my multiplication and division. Next in my solving process, I'm going to divide by negative 4 on both sides, and I get x is equal to positive 7. So I should have the solution now to my system, which is going to be the coordinate point of x, which is my x coordinate first, 7, and negative 1 for my y. That would be my solution. One last little bit before we leave. Let's look at what that is graphically. Now I went ahead and since it was in standard form, I found the intercepts for these. So you can see that I went ahead and pre-solved the intercepts for you. You can follow along on that on your own accord. Okay? But I've graphed both of those lines. And you can see here's the first of our linear equations and here is the second. And I've graphed them for you. And what you should see, and I graphed it fairly accurately, is that this point happens to be at a little bit off because this blue line's a little off, but it's right there. There's a negative 7. It should be pretty close to that, and this value of negative 1, which would confirm. So what we would do here, if you graphed a little bit more accurately than I did, is that this would be your check to see if you did this elimination correct. Or more importantly, that you understand what you're doing. What am I doing when I do elimination? You are finding that point visually that's represented by those two lines intersecting, or better referenced as the intersection point, or point of intersection. All right, there you go for your section of notes. I will have a couple of videos here that do some more examples for you, but then we'll see you in class.